know. So we'll see outcrop. So outcrop means in simple word you can say it is a visible exposure of an ancient deposition of subsurface. Any deposition that present below the surface after erosion, it will expose to the surface. So that exposure is called as your outcrop. That exposure is called as your outcrop. Something how it is cropping to the surface, how it is cropping towards the surface. Suppose this is our horizontal, or this is you can say ground surface. So if any bed present below the surface, we cannot see the whole bed. If it is present below the surface, this part we cannot see. We can only see this surfacial exposure part. So if you are standing here, you will only see this strip like exposure, but they actually represent a bed below the surface. So from this exposure, we can also define various property of the bed, like what is the dipping direction, and you can say the visible exposure. If it is on a horizontal ground, it will be the strike. So all thing you can determine from here. But this exposure, it is simple that cropped out after erosion. Cropped out after erosion. Suppose the bed like this, okay. So when they expose to the surface, so you only see this part. So you only see this part only, because below this they are under the surface. So outcrop, simple, it is a visible exposure of an ancient deposition of subsurface region. Anything that below or deposit below the subsurface, with time it exposed to the surface by erosion. So when superficial part will erode, then it will uplift the subsurface part. So it gradually exposed to the surface. Another thing, there the exposure can also be in mountain condition. There will be more exposure, more rocky exposure you will find in mountain condition. So here you can find the exposure. If this is a mountain wall or something, that is you can take a fault, scrap, anything. Imagine ki this is anything that exposed on this wall, so that you can easily see, ki this is a bed, how much it is inclined. So that you can also get any exposure on a you can say road cut mountain surface. So from this outcrop exposure, you will able to define different type of structure, because different type of structure will produce a pattern of exposure, that is called as outcrop pattern. So from that pattern, you will know the type of structure, or you can say a different type of fold, a different type of fault you can also determine from this pattern. So suppose here we are getting these outcrops. So when you will examine, you will get this is one bed, this is another bed, this is another bed. So there are 5 beds here in a sequence. So it will indicate something. There are 5 beds present here in a sequence. And from this exposure, you can measure the dip and strike of the bed. So we use this symbol. This is your strike. This is dip. All are direction. Strike direction, dip direction, and if you write down something here, it will be the dip amount. Suppose I'll say this bed, it has strike, and this is your dip. I'll write down this is suppose 50 degree dip. So in an outcrop pattern, this thing is also mentioned to what direction the bed is dipping and what is the amount of dip. So this is the you can say expression or symbol for the strike and dip. Strike direction, dip direction, and dip amount. So here also, so when we'll represent it, it will be like this. Suppose 1, 2, 3, 4. This type of diagram will do. So where the bed are dipping in the same direction. The bed are dipping in the same direction. You can say this is a homocline. If all the dip amount are same. Understood? So this is a simple outcrop. So first we will see the outcrop of a fold. How a fold will expose to the surface. So next comes to outcrop pattern of the fold. Now how the exposure pattern will indicate a presence of a fold. So see, so when a fold will expose to the surface, it will also produce parallel lines. Depending on the type of fold, it can produce curved line, but first we'll see straight line condition. So it will produce these straight lines on the surface. So you are on the surface. This thing is not visible to you. This is below the surface. So you are only seeing these parts. So when you examine, you will find this is one bed. You will number this as 1. This will be 2 bed. This is 3 bed. Again, you are getting the same bed here. 2. Then 1 bed. In any exposure, in any outcrop exposure, if the bed repeats in this manner, if the bed repeats in this manner, like 1, 2, 3, 2, 1. If the bed repeats in this manner, or you can say A, B, C, B, A, or A, B, C, D, C, B, A. If bed repeats in this manner, it will be considered as a fold. So this is the outcrop pattern of a fold. So if you are examining any more a bed on the surface, if you see this repetition pattern, so this will be a fold. This will be a fold. So this is the outcrop pattern of a fold. So this is the outcrop pattern of a fold. So these are your fold limb. These are your fold limb. এটা বুঝি পাচ্ছ না বুঝবা না? Fold limbs are simple. Those are inclined beds. Fold limbs are these are inclined beds. So they will expose to the surface like this. So see, this is a fold. It is, you can say from this side, you can say it's inclined, but you cannot see this side. So when it is exposed, it will exposed by this straight line, like an inclined bed, because this limb of an incline, it is an inclined bed. These are inclined bed. They will expose to the surface as straight lines. So then if you add other information, then you can able to tell what type of fold. So this repetition pattern only confirms that it is a fold. Now we'll put some information. So it will give you the type of fold. So first we'll see. Suppose we have an outcrop pattern. Like this. This is your A bed, B bed, C bed, then again B bed, A bed. So this will be a fold. Now we'll see the dipping pattern of the limb. If it will be like this, then it will consider as a antiform. It will consider as an antiform because limbs are dipping away from each other. From this you can say limbs are dipping away from each other. So see, so this is a fold. So before your exposure, it will be below the surface. So when it will erode, it will expose the surface. So this will be one bed. Suppose this will be one bed. When it will expose, this will be our one bed. This is also our one bed. Understood? Then this is number 2 bed. It will expose here. This is 2 bed. So now see, this is 1 bed. So when you examine this, you will get a dip to this direction. This will be in this direction. Similarly, for 2 bed you will get dip in this direction. For 1 bed you will get dip in that direction. Okay. Now this 3 bed, you will see this 3 bed. So it is exposed in a single strip, but others are exposed in different strip. So now if you will examine, some part you will get deep in this direction and some part will be in the opposite direction. Understood? And you will get the repetition pattern. Suppose there are 1, 2, 3, 2, 1 here. So understood? So if you put some information on the outcrop pattern, then you will able to tell what type of fold it is based on the based on the information. So this much information if you have is given here, ki this is ki beds are dipping away from each other, you will only tell this is an antiform. So in similar case, if I will say this is older, this is younger, then it will be a. Now see, according to the bed dipping pattern, it will be an antiform. Then this central part, it indicates the core. So this will be the core. These are periphery. These are periphery. This is periphery. So this is core, this is periphery. So the core part, it contains younger rock. So any fold they contain the younger at the core, it will be called as syncline. It will be called as syncline. So here the form is antiform, so it will be antiformal syncline. It will be antiformal syncline. Now suppose here we have a fold, because from the repetition pattern you can tell it is a fold, and the beds or limbs, they are dipping towards each other. That means it is a synform. That means it is a synform. So in synform, we'll suppose getting younger rock here, older rock here. Then you can simply tell that it is syncline, or you can say synformal syncline. Can easily tell that it is synform, and you are finding younger rock at the core means it's syncline. So synformal syncline. So these things, this type of question you'll get, whether in question there the older and younger it is written. Otherwise you'll find some structure which will indicate the younging direction or your older direction. So suppose we'll do a cross bedding here, like this. We'll do a cross bedding here. Okay, this is a cross bedding. Now what type of fold it will be? Tell me. See, this is a cross bedding here, represented here. So we know that this part, the truncated part where the forested bed meets the upper bounding surface at higher angle. So it will be top side, it will be bottom side. It will be top side, it will be bottom side. So top side always younger, bottom side indicate older. So this side will be your younger side. So younging direction you are getting towards the periphery. So younging direction towards periphery means it is anticline, and the form is synform. It will be synformal anticline. It will be synformal anticline. So mostly tomorrow jete bhi question tha, mostly question you'll see this cross bedding or a current ripple. Sorry, wave ripple. Mostly you'll see current ripple, wave ripple and cross bedding. So wave ripple also it show top and bottom criteria. You know, this is the crest part, sharp part it is top, it is bottom. So you can find a cross bedding, you can find your wave ripple or any type of structure that will indicate the top side and bottom side or younger side and older side. So then you can determine the type of fold. So see, first from the outcrop pattern it is a fold. As they are dipping outward, we can say it is an antiform. It is an antiform. and then they are dipping at the same direction, same amount, it will be a symmetrical fold. So simple, you can say symmetrical antiform fold. Symmetrical antiform fold. If you put some other information like this is older, this is younger, so it can be called it as an anticline also. So if there is a MSQ question, then it can be antiform, it can be a symmetrical fold, it can be a anticline, it can be antiformal anticline, it can be a symmetrical antiform, symmetrical anticline, but you can say anything. Okay. So basically this type of fold, it is a symmetrical fold. It is a symmetrical fold where the limbs will dip at equal amount. See, next, in this type of fold, if folds or limbs are dipping in the same direction, first thing, it is an overturned fold. It is an overturned fold. If limbs are dipping in the same direction, so it is like this. This overturned fold where the limbs are dipping in the same direction. It is like this. So limbs are dipping same direction means it is an overturned fold. It is an overturned fold. Now see, so previously we have discussed all type of fold. They are producing your outcrop of the limb. They are parallel to each other. So when the outcrop of the limb they are parallel to each other, they are producing a straight line. The fold is non-plunging. So all the type of fold that we have discussed before, all are non-plunging fold. All are non-plunging fold. Suppose you'll see this. This is horizontal. This is horizontal. Now this fold is not plunged. So if you see along this line, you will get straight line. When it will expose to the surface, it will produce straight lines. Now, if this is inclined, if the fold axis is inclined or hinge line is inclined, then it will produce a curved line. The outcrop pattern will be curved line, or they will converge towards each other. They will intersect. So outcrop line will intersect when the fold will plunge. So the outcrop line will intersect when the fold will plunge. You can see this is your you can say a horizontal condition. So it will expose on this line. It will expose on this line. If you bend this, see, so before the exposure line is here, okay, so on this line, so before it was here, it will produce a straight line, okay. So if it is inclined, the straight line will remain like this. So you draw a straight line here, you draw a straight line here, they will converge at this point. They will converge at this point. They will converge. देखो white को white है जो ज़्यादा एमती रहिला. This is your normal type of fold which is not plunged. If it is plunged like this, it will plunge like this. So the outcrop will be in the horizontal direction. Outcrop will be in the horizontal direction. So if you draw a line, see these are actually line that horizontal. Okay, so if you draw a line here and on the other side in inclined condition, now see these line will converge like this. This line will converge like this. If it is a non-plunging fold, if it is a non-plunging fold, then exposure will be here. Then exposure will be here, horizontal. So they will produce a straight line. They will produce straight lines. Understood? So remember, in non-plunging fold, the outcrop lines are straight. The outcrop lines are straight and parallel to each other. You can say outcrop lines are straight and parallel. But in a plunging fold, the outcrop line will be curved. The outcrop line will be curved. Suppose these are two examples. This is non-plunging fold. Non-plunging fold. This is your plunging fold. Both are synclined or synform, you can say. Both are synform. So here you will get straight line, like the outcrop pattern will be so the outcrop line will be like this. This will be the outcrop line for this fold. Actually, this type of diagram we call them as block diagram, and this is your outcrop pattern diagram. Okay, and if you draw the outcrop pattern of this plunging fold, so it will be like this. As this it is a syncline, you can say mention this also, where the limbs are dipping towards each other. And in plunging fold, we have to show the plunging direction. We have to show the plunging direction. So here see, it is a syncline with a syncline. So in a syncline, this is the fold axis or hinge line. This will be the fold axis or hinge line. Okay. So suppose you see, this is a plunging fold. Okay, this is a plunging fold. So outcrop pattern will be here. These lines are outcrop lines. So the fold axis is plunging in this direction. Fold axis is plunging in this direction, or hinge line, the plunging direction is in this direction. Now this see the outcrop pattern in a syncline fold, they will plunge, they will converge in the opposite direction of the plunge. So here see, if it is a syncline here, now see, these will converge in this direction. These will converge in this direction, but the fold axis is plunging in this direction. Okay, the fold axis, what will be the plunging direction? If this is a fold axis, so what will be the direction of the dip or a plunge? Sorry, in this direction, and the outcrop are closing towards this direction. So here, this thing may be mentioned or may not be mentioned. If the plunge direction is mentioned, you can tell whether it is a synform or antiform, whether it is a synform plunging or antiform plunging. So as this is a synform, so you have to show the plunge direction opposite to the closure. So if we'll show the plunge direction towards the closure, it will be antiform. So it will be synform plunging, it will be antiform plunging. So this is your plunge direction. So plunge direction. Amount may be written here. You can write down amount 30, 20. These are also written near the direction. So now you'll see this is the trend or plunge of the fold axis, and this is the plunge of the fold axis. If the fold outcrop closes in the direction of the plunge axis, in the direction of the plunge direction, it will be an antiform. If the fold outcrop closes in the direction of the plunge of the fold axis, it will be an antiform. If it closes opposite, it will be an synform. So now we'll move to antiform. So in antiform, this will be the outcrop line. This line is outcrop line. This line is your outcrop line, and this is the fold axis. This is the plunge direction, and they are closing towards the plunge direction. They are closing towards the plunge direction, which is opposite in case of synform. So remember, if the fold axis plunges in the outcrop closer direction, it is your antiform plunging. If it is opposite, it is synform plunging. Next, write down if the trend of the fold axis. Write down if the trend of the fold axis, if the trend of the fold axis is parallel to the axial trace. If the trend of the fold axis parallel to the axial plane trace, then in that type of fold, the fold axis is horizontal. In that type of fold, the fold axis is horizontal, or you can say horizontal fold. Horizontal fold. Or the axial plane is vertical, you can say upright fold. So suppose if the fold axis is horizontal, means the fold is non-plunging fold. The fold is non-plunging fold. Suppose if this is the trend of the fold axis, so it will be horizontal. It will be horizontal. That means you can show any direction. So this is the trend of the fold axis. Then the axial trace will be this one. Axial trace. This is fold axis. So if in any type of fold, in any type of outcrop pattern, if you see the fold axis, it is parallel to the trace of the fold axis is parallel to the axial trace. That means it either be a horizontal fold or be a upright fold. It can be a horizontal fold, can be a upright fold. That means in this type of fold, either fold axis is horizontal or axial plane is vertical. It will simply a plunging fold. It will be a plunging fold. But if the axial trace is the axial trace, suppose this is the plunging direction. This is the plunging direction. This is 20 degrees suppose. So this is axial trace. This is plunging direction. So see here it is the plunging direction. Plunging direction same as your closing direction. It will be antiform plunging. But here the axial trace, it is parallel to the fold axis. The trend of the axial, trace of the axial, axial plane trace and trend of the fold axis, they are parallel to each other. So it will be an upright fold. It will be an upright fold, but the plunging one. You can say it is. You can say it is an antiform. It is also correct. You can also say it is upright plunging. You can say upright plunging. You can say antiform plunging also. But as it is here from this relationship, it is evident that the axial plane is perpendicular, so it will be an upright plunging fold. So this can be an horizontal fold. This can be an horizontal fold when fold axis is horizontal to the axial plane. It is horizontal fold. No plunging here. This is upright plunging fold. Next comes to another type of fold. It is called inclined fold and reclined fold. These two very important. Reclined is very important. So first see inclined fold and reclined fold. So from the definition, an inclined fold where the fold axis and axial plane inclined, then reclined fold where the axial plane deep is equal to plunge of the fold axis. Axial plane deep is equal to plunge of the fold axis. So the outcrop pattern of inclined fold, remember here, if this is so this will be your axial trace. This will be your axial trace. So this will be axial trace. The trend of the fold axis, it will be inclined to the axial trace. If in an outcrop pattern, This is your axial trace, and this is the trend of the fold axis. If axial trace, trend of the fold axis, they are inclined to each other, it will be your inclined fold. It will be inclined fold. And in reclined fold, you will find that. So in reclined fold, this is the axial trace. The trend of the fold axis is approximately, suppose 90 degree from the, it is approximately 90 degree from the 80 to 90 degree. You will find pitch here in reclined fold. Approximately 90 degree from the axial trace. If it is 90 degree from the axial trace. So axial trace is a plane, axial plane, it is a planar thing. Fold axis is a line. Axial plane is a plane. Fold axis is a line. If fold axis is a showing 90 degree pitch, if fold axis is showing 90 degree pitch, that means the fold axis is in the direction of the axial plane true dip. It is in the direction of the true dip of the axial plane. So that's why the plunge amount of the fold axis will be equal to the dip amount of the axial plane. So see, this is an fold where axial plane is inclined. If you are, this is our axial plane. Okay, this is axial plane, inclined fold. If you draw any line, imagine parallel to the strike line of this axial plane. So that will be the trend of the fold axis. Because fold axis trend is in this direction. So if you draw a line parallel to the axial plane, this will be the axial plane. Okay. So if this is axial plane, so this will be the fold axis. So here you can see it is parallel to the strike of the axial plane. So pitch is 0. Pitch is 0. So keeping this thing constant, if you rotate this, if you rotate this like, keeping the axial plane like this, if you rotate this, then the pitch will change. Keep the axial plane constant, okay? Axial plane will be like this, but the fold will in deep like this, okay? So if the fold will deep like this, then these your plunge of the fold axis will change, and also it will make an angle with the strike line. So with gradual dip, when it is the pitch is 90 degree, it will be considered as your reclined fold. So see, so these folds are called as inclined fold. Simple. These are fold called as inclined fold. Suppose see, this is a fold which is horizontal. Okay. Now this is inclined. This is inclined plunging. So this is the axial plane here. If you dip this thing or plunge this thing in this direction, the axial plane will remain in this orientation, but the pitch, it will change. The pitch will change. So pitch in between 0 to 90 or plunge in between 0 to 90, it will be your inclined fold. If pitch is 90 degree, that means this is an axial plane, this is an plane. Anything that pitch perpendicular to this plane, anything that pitch perpendicular to this plane, it will have a dip equal to the dip of the plane. It will have a plunge equal to the dip of the plane. Any line pitch perpendicular to the strike line. That means any line pitch at 90 degree means it is perpendicular to the strike. So suppose a line here. Tomorrow plunge direction. So this is your strike line of the axial plane. So the in reclined fold, the the fold axis will be in this direction. Will be here. So if it is here, then the pitch will be 90 degree. And that way I will say the axial, the dip of the axial plane and the plunge direction of the axial fold axis, both are same. The plunge direction of the fold axis and dip of the axial plane both are same. If both are same, also the amount will be same. So that's why it is a reclined fold where pitch will get 90 degree, or perfectly you will not get 90 degree, you will get in between 80 to 90 degree, where the plunge angle will be equal to your true dip angle, or plunge angle will be equal to the dip of the axial plane. So here reclined fold where the fold axis almost in a direction that is perpendicular to the axial trace direction. So that's why in a reclined fold the deep here, see it is the plunging amount of the fold axis. If this is the plunging amount of fold axis, then the axial plane also has 40 degree dip. So this is your inclined and reclined fold. Also write down in recumbent fold, you will get fold axis horizontal, axial plane horizontal, but the plunge never exceeds 10 degree. Plunge is always less than 10 degree. So you will also study it in a PYQ classification, where the plunge of the recumbent fold is less than 10 degree. So then next comes to any depression or culmination along the fold axis or hinge line, any depression or culmination along the fold axis. So see, suppose we will do a diagram here. This is an antiform, this is the depression, so it is a doubly plunging fold. It is a doubly plunging fold. So the outcrop will be according to the plunge direction. So this is our plunge direction. So here we are getting plunging towards each other. So it is an antiform, means the outcrop will close in the plunge direction. Outcrop will close in the plunge direction. So the outcrop will be like this, see. Up to this point, the outcrop will close in that direction. Up to half you can see here, plunge will be, the outcrop will close in the plunge direction. In this direction also they will close towards the plunge direction. So they will produce a pattern like this. So this is an antiform with axial culmination. Antiform with axial culmination. So antiform with axial culmination. This is axial depression. This is an antiform with axial depression. तुमने बस किसी भी कहबनी एटा तुमको कल्मिनेशन देखा होतला किछ नै खाली लिखि देबा मुआ लेख सुनिनु बोधे कान कोन देइथिलु बोधे. So it is antiform with axial depression, it is synform with axial depression. So we will give this arrow mark here to show whether a culmination or depression. If arrow marks towards each other, they are depression. Arrow mark plunging direction. कौन दिया plunging direction दिया होची. So here, first thing, if outcrop closes opposite to the plunging direction, it will be synform. Okay, and this shape is called as your diamond shape. It is called as your diamond shape outcrop, and this is called hourglass. So this is your culmination part where the fold will plunge away from each other. So, and if it is a synform, then it will the fold will close on the opposite direction of the plunging. So it will produce a hourglass structure, synform with axial culmination. And this is antiform. The fold will close, outcrop will close in the direction of the plunge. So it will produce a diamond shape. So it will antiform with axial culmination. So hourglass with your arrow pointing away from each other, it will be synform with axial culmination. So from the outcome, first thing we are seeing it is a plunging fold, and as the outcrop is two types, they are pointing two directions, there will be doubly plunging fold. It will be doubly plunging fold. Now see, so here the outcrop, they are closing in the direction of the plunge. They are closing in the direction of plunge means it is antiform. And along this fold axis, the plunge is dipping towards each other. The plunge is towards each other means it is a depression. So antiform with axial depression. So antiform with axial depression, synform with axial culmination, both have same pattern. Only difference here is plunge direction is away from each other. And how will know it is synform? Because plunge direction, it is opposite to the fold closure or outcrop closure. Here plunge direction is opposite to the outcrop closure. It will be also synform, and they are dipping towards each other. It is also a depression. So synform with axial depression. So synform with axial depression. एग्जाम रे तुमको डायग्राम देते पचारियो सिंपल गेट रे भी जीएसआई नेट रे जीएसआई रे जोथ रे बहुत इंपोर्टेंट इनसाइट. So then comes to where the fold axis is absent or hinge line is absent, that is your pericline fold. So pericline fold, it is your dome and basin and pericline fold, it will produce a circular outcrop. The important thing is it is produce a circular outcrop like this. They will produce circular outcrop. So from the plunge direction, they will plunge in all direction. From the plunge direction, we will know whether it is a dome or basin. This is dome. The outcrop will be same for both. Only the dipping plunging direction, they will show whether they are dome or basin. So in fold, you will get straight line outcrop, you will get curved line outcrop, you will get circular outcrop. So circular outcrop means it is dome basin. And these diamond shape, they can be elliptical like type of thing. So you will get the different type of outcrop in a fold. But important thing, they should maintain that repetition pattern. They should maintain the repetition pattern. So repetition pattern, you will see that will confirm your fold condition.